Today's lead code daily streak problem: binary prefix divisible by 5. You are given a binary array nums which is 0 indexed. We define xi as the number whose binary representation is the subarray of nums of 0 to I from most significant bit to least significant bit. For example, if nums equal to 1, 0, 1, then x naught equal to 1, x1 equal to 2, and x2 equal to 5. Return an array of booleans answer where answer of I is true if xi is divisible by 5. Simplifying this description, we are provided with an array nums which is by default 0 indexed. This is binary array. Now we have to build numbers step by step with each iteration, and we only want the binary digits, we only want the binary bits which are divisible by 5. So let me switch to the notepad. Now let me take an example. I have an array nums with binary bits 1, 0 and 1 in this sequence. Now the build, first let it be x naught or x0. This is the binary formed by nums of 0. Here nums of 0 is 1. So 1 in binary is represented as 1 itself. Now x1 is binary formed by nums of 0 to 1. So 1 0 in binary, in decimal its representation is 2. Now for x2 it's nums of 0 to 2, which is 101 in binary, and decimal representation is 5. Now among these representations only x2 is divisible by 5. The core is whether the binary is divisible by 5 or not. Now the key concept in this problem. The main question is about how do we update when a new bit comes. Here this is the conceptual dry run, conceptual analysis, but in programming point of view, the main question is how do we update when a new bit comes in the next iteration, in the new iteration. Now the basic point is, in decimal, when the numbers are represented in decimal form, the base is 10. Similarly, when they are represented in binary, the base is 2. So this is the core point. Since we are dealing with binary, now we will use the base 2. Say x of I is the number yet to be formed, in present iteration. number to be formed in present iteration. So when we are dealing with present iteration, we will connect this present iteration to the past iterations, to the recent most iterations, because we want our present iteration, we can obtain the present iteration only when we consider our past iterations too, our recent iterations. So when x of I is the present iteration, by default x of I minus 1 is the number formed till the recent iteration, till the recent most iteration, and new bit is either 0 or 1. Let it be b. Now if I want to write it in equation form, x of I equal to x of I minus 1 into 2 plus b. This is the equation. Now we have to confirm whether it's divisible by 5 or not. So adding modulo 5. Now analyzing the same sample test case in this programming point of view. Now another basic point is a number is said to be divisible by 5 only when its remainder is 0. The remainder should be strictly equal to 0 for it to be divisible by 5. This is the basic rule. And okay, now let's start our iteration. Initializing remainder equal to 0. Now I want to convert this equation into the terms of remainder. So how do I do it? Remainder is remainder into 2 plus b modulo 5. Now what I have done here is I appended a bit by multiplying it by 2 and adding the present bit. Here I replaced x of I with remainder and x of I minus 1 also with remainder, because we are only concerned about the remainder. The core of the problem is we want to check whether the remainder is 0 or not for optimization. Now as we initialized remainder equal to 0, here according to this equation the remainder is 0 and this b is, now say I equal to 0. Now nums of I is 1. Now b value is 1. Modulo of I is 1. Again, when I equal to 1, this remainder gets updated. This remainder gets updated. This remainder gets updated. Now the new remainder is 1. 1 into 2 plus b is 0. Again, it's 2. Now the new remainder is 2. When I equal to 2, the remainder is 2 into 2 plus the b is 1 modulo 5 is 0. Now here the new remainder is 0. According to the problem, we have to return a Boolean array reporting the results. Now the first binary bit is not divisible by 5. Here I got the remainder as 1. So it's false. Again, in second iteration, I didn't get the remainder 0. It's false. In the third iteration, I got the remainder as 0. It's true. So this is the final result. This is the dry run of the problem. Now let me code the solution. Here we declare a list because we are uncertain about the size of the result. So using list is the best optimal way. The list contains Boolean data. Initializing remainder with 0 first. Okay. For int, initializing the for loop as usual. Now rem equals remainder into 2 plus nums of I modulo 5, and we have to add the result, whether it's true or false, to the list. We add the result based on the condition that remainder is 0 or not. If remainder is 0, it adds true to the list. If remainder is 1 or 2, it adds false to the list. Now return answer. So this is all